Hello everyone, today in this video we are going to derive three equations of motion using calculus method. So after this video you should be able to derive all three equations using calculus method. So these are the two formulas which we will be using to derive the equation. So first formula is velocity is rate of change of position, and second formula is acceleration is rate of change of velocity. First equation, so first equation is v is equal to u plus at. So this is the formula which we are going to derive. So we have two formula to use, so let us see which formula should we use. Now out here we don't have displacement, so we should use formula of acceleration because we don't have displacement out here. This is the starting. So by definition acceleration is rate of change of velocity with time. So I can write a is equal to dv upon dt. So I'll multiply this t this side and I'll flip the equations. So final equation is dv is equal to a dt. Now I'll integrate both sides. So the limit of velocity is from u to v. U is initial velocity, v is final velocity, and time is going from 0 second to t seconds. So we'll integrate this way. So these are the limits of integration. So velocity going from u to v, time going from 0 to t. So out here a is constant, so I can take this out, and integration of dv is v, and limit is starting from u to v, and integration of dt is t, as a is constant which will come out, and limit of t is 0 to t. Now I'll put the value. So for v I'll put v once minus lower limit u. Similarly for t also, upper limit is t, lower limit is 0. So now when you open this bracket, take this u to right hand side and we'll get the first equation of motion. Final velocity is equal to initial velocity plus acceleration into time. So now we'll derive third equation because first and third equations are somewhat similar. This is third equation, and again I have acceleration and velocity, so I'll use the formula for acceleration, and we have displacement also, so in between we'll put the displacement also. So by definition acceleration is rate of change of velocity, a is equal to dv upon dt. So I'll multiply both sides with dx because we want displacement also in the equation. So I'm multiplying dx to both sides, and now I'm taking this dv that side and I'm keeping dx with dt. So now for dx upon dt I can write v because the rate of change of position with time is velocity. So for dx upon dt I'll write v out here. Now we'll integrate both sides. I'll take the limit of velocity from u to v, and limit to the displacement is starting from 0 to s. So I'll integrate. So displacement is 0 to s and a is constant, it will come out. Out here the limit is from u to v, and I cannot take this v outside because we are integrating with respect to v only. So integration of dx is x, and integration of v to the power 1 is v square by 2, and limit is out here 0 to s, out here u to v. And now I'll put the value. For x I'll put s once minus 0, and for v square I'll write upper limit v square minus lower limit u square by 2. So s minus 0 is s. So if you multiply this to this side, you will get 2as is equal to v square minus u square. So this is third equation of motion. And now we'll derive the second equation. In second equation we have displacement, so we'll use the formula with displacement, that is v is equal to dx upon dt. So by definition velocity is rate of change of position with time. V is equal to dx upon dt. So now I'll multiply t this side and I'll rearrange the equation. We don't have v in second equation, so I'll put the value of v from first equation. So using first equation, v is equal to u plus at. So now for v I am writing u plus at. Now I'll integrate both sides. So the limit of time is from 0 to t and limit of displacement is from 0 to s. So this is integration of dx is equal to integration of u plus at dt 0 to t. Now I'll open this bracket. Now I'll integrate. So integration of dx is x and limit is 0 to s, and integration of u dt, u is constant, so integration of dt is t, plus in a will come out because it's a constant, so integration of t dt is t square by 2 and limit is from 0 to t. So I'll put the limit. For x I'll write s minus 0, and for this t I'll write t minus 0, and for this t square I'll write t square minus 0 square. If you simplify this, you will get s is equal to ut plus a t square by 2. So if you rewrite the equation, you will get this, and this is the second equation of motion. To derive first and third equation, we use the formula for acceleration, and to derive the second equation, we use the formula of velocity. And this is the end of the video. Please don't forget to like the video and subscribe the channel. Thank you.